Assalamu alaikum. Hope all of you are doing good. So in this lesson, you are going to learn about calculus, basically differential calculus. So what basically calculus is? Calculus is mainly divided into two branches. One is a differential calculus, and the other one is an integral calculus. So in an integral calculus, we basically calculate area under the curve of function, while in a differential calculus, we basically calculate rate of change or instantaneous rate of change of a function at a point, at a given point, at a specific point. But what actually derivative tells you, it basically tells you or explains you about the behavior of function at a very specific point. So in an integral calculus, what basically integrals tells you or explains you, it basically accumulates all the points or values of a function over a wide range. So basically, integrals is related to the sum of the things, while in differential calculus, we basically calculate rate of change. So first, today we will discuss about derivatives. What are derivatives? How they are related to the concept of limit. So let's get started. First, we will consider a graph of any function. Let's suppose this is our x-axis and y-axis. This is x-axis and this is y-axis. Now we draw a curve of f of x. So this is a function f of x. So now let us take 2 points. Let's take point P is here, and this is point Q. So the coordinates of Q are x plus h, comma f of x plus h, and this is the coordinate, this is point P, and coordinates of P are x comma y. So now we want to calculate the gradient of this line pk, which is a secant line. So in order to find gradient, you have to draw two perpendiculars in order to calculate rise and run, so that you can visualize it properly. This is point P and this is point Q. And now draw a triangle here. So this is x and this is x plus h. So what is this value? This is delta x, which is equal to x plus h minus x. And what is the value of this? So this is f of x plus h. This is value of y at point Q, and the value of y at point P is y. So which is equal to f of x. Since we have y equal to f of x, so this is equal to f of x. So this whole value is equal to f of x plus h, and the value from this point to this point is equal to y, which is equal to f of x. So we have f of x plus h minus f of x. So now we want to calculate gradient of this line. So in order to find gradient, we first define what gradient actually is. So in your lower grades, you have already calculated that the rise over run is known as gradient, which is also known as slope, rise upon run. So this is equal to f of x plus h minus f of x. So this is f of x plus h minus f of x divided by x plus h minus x. So if I cancel out this x by minus x, so we have f of x plus h minus f of x divided by h. So this is the gradient of the line PQ. So that is what we call basically average rate of change between the point P and Q of the curve. So if you look at this curve, the gradient is keep changing it. If you take two different points, and then gradient will be different from the gradient of the line PQ. So what you have to do, you have to calculate the gradient at each and every point. So in order to do this, we have to squeeze this delta x so small that this point Q will move to point Q P, sorry. So now how can we do this? If you take small values of h, this h should be small, so that point Q will move towards point P. So if we take smaller values of Q, it will come here, then come here, then come here. So if you take delta is so small that this line, that this secant line will become tangent to the curve at point P. Sorry. So this line will become tangent to the curve at point P. So I should take a different color for this. So this will become tangent at point P. So if we want to calculate this gradient, so this will become this value will become gradient of the line at point P. So how can you do this? You have to adopt a method of limit. So apply limit h approaches to 0, delta y upon delta x is equal to limit h approaches to 0. This is equal to f of x plus h minus f of x. So divide by h. So this value on the left hand side will become f dash of x, and this is equal to limit h approaches to 0. So f of x plus h minus f of x divided by h. So this is we call first principle method or AB initio method of finding derivatives. So what about the existence of the limit? So what about the existence of limit? So limit exists if the left hand derivative and the right hand derivative exist. Then we say that the function is differentiable at point P. So you have to calculate this limit in order to calculate derivative. Also, I want to tell that there is a delta x and here is h. So both are equivalent. So if h tending to 0, if h approaches to 0 implies that delta x is also approaches to 0, because we are taking small values of h. As h goes to 0, then this delta x will become 0, because point q will coincide to point p. So now how can we calculate derivative using this formula? Acha, it has another form. Let's suppose f dash of a. If you take two different points here, this is x approaches to a, so this is equal to f of x minus f of a divided by x minus a. So both are equivalent. We can apply any one of them. This is the derivative at any point a of the function, while this is the derivative. This is the general rule for differentiation. So that is what we call derivatives. So hope you understand this lesson. So inshallah we will do some of the questions in the next lecture shortly. So thank you. Allah Hafiz.